We'll look at these tubes edge on so that they appear as circles. Here's our larger tube, and it'll roll along until it reaches the smaller tube. It'll roll over it until it reaches the other side, and then it will keep rolling. I'll draw these radii to the point where it's tangent to the surface. So this distance from start to finish is x. We'll call this distance from the point where the larger tube is tangent to the smaller one to the point after it rolls over but is still tangent. We'll call this distance d. First, let's find d. I'll redraw the diagram with our larger tube and our smaller tube. Let's let this center be O and this one is P. We'll connect the centers of these two circles. The larger tube has a radius of 72 and the smaller is 24. I'm going to draw this perpendicular and we'll call this point Q. So we have right triangle OPQ. The hypotenuse is 96. We can find OQ by subtracting the two radii, so that's 48. We notice that this is twice the length of the shorter leg, so this is a 30, 60, 90 triangle, and the distance from Q to P is 48 root 3. So this distance D is 2 times the distance from Q to P, or 96 root 3. Let's see how much does the big circle rotate as it rolls over the small tube. I'll redraw our tangent circles again, and we'll call this point R right below P. We'll find angle OPR. This was a 30, 60, 90 triangle, so we have a 30-degree angle here, and then we'll add this right angle. So OPR is 120 degrees. After the large tube rotates over the smaller tube, it'll end up over here, and I'll call the center of this other circle O prime. So 120 degrees is also the measure of angle O prime PR. So this angle up top, angle OPO prime, is also 120 degrees. Let's call this tangent point T, and the one on the other side will be S prime. On the tube in its original position, it's going to be up here somewhere, and then it's going to rotate down until it touches the smaller tube. This arc from T to S prime between the two tangent points, as measured on the small tube, is going to be 1/3 of the circumference of the circle P. That's 1/3 2 pi r, where the radius is 24. So the length of this arc from T to S prime is 16 pi. Since the tube doesn't slip as it's rolling around, that's going to be the same as the length of the arc from T to S on the big tube. Let's find this angle, SOT. This is going to be the ratio of the arc from S to T over the circumference of the big tube times 360 degrees. That's 16 pi over 2 pi r, where the radius is 72. So this angle is 40 degrees. And now we'll find angle SOQ. We have a 60-degree angle over here, so this angle is 100 degrees. So our large tube starts off like this, and this angle is 100 degrees. And when it's finished rolling over the smaller tube here at O prime, S will map to S prime, where this angle is 60 degrees, symmetric with the other side. So the total rotation from S to S prime, it'll go 100 degrees to get down here, plus 60 additional degrees to where it becomes tangent for 160 degrees in rotation. Since the larger tube rolls until it comes to rest on the same point as where it started, it will have rotated a total of 360 degrees, including this 160 degrees. So subtracting from 360, the tube will also rotate 200 degrees on the flat surface. We'll translate 200 degrees into a horizontal distance by figuring out what fraction of the circumference that is. The circumference of our larger tube is 2 pi times 72. Multiplied by this fraction, that's a distance of 80 pi. So our total distance x is going to be this 80 pi plus d, the horizontal distance as it passes over the smaller tube. This was 96 root 3. We're asked for the sum of a, b, and c, and our answer is 179. If you'd like me to solve any other math contest problems, please leave them in the comments.